Hello, sir.
Yeah. Chika, are you there?
Yes, I'm here.
Are you ready?
Yes, sir, I'm ready.
Yeah. So look at chemistry, Abby.
First question.
Yeah, chemistry first question 2018. 2018.
Okay.
Is that what you have?
I have that too.
Okay.
Down on the page. He said, which of the following raw materials is used for plastic industry?
Okay.
Used in the plastic industry. A, ethane. B, methane. C, sulfur. D, hydrogen.
Wait, I'm trying to open the question on my own. Okay, yeah. This is 2019. Okay, I told you
And
also.
the one I sent yesterday is 2018.
Yeah, let's work on 2018 first, Abby.
Yes.
Yeah, I'm going through the chart you sent me, checking the question for 2018. I'm seeing what you did well. Okay. So I'm in 2018 now. Which of the following raw materials is used in the plastic industry? Okay, that's the question, Abby.
Yes, sir.
So what are the options?
A, ethane.
We have ethane, methane, sulfur, and hydrogen.
Hydrogen.
Okay. So which did you pick as the answer, and why did you pick that as the answer?
I picked ethane.
Okay.
Because one of the uses of ethane, if you check when doing like ethane, you see that ethane can be used as a raw material in plastic industry.
Okay. So I'm gonna share my screen and show you something. Okay. Now continue. Read out the number 2. Tell me the answer while I open up what I want to share with you.
Which of the following organic compounds under substitution reaction? A, pentane. B, benzene. D, hexane.
Which
They
undergo what?
don't under their chemical properties, addition and substitution.
Okay.
Propane, hexane, and pentane. Their chemical properties not to undergo addition or substitution reaction, but is the chemical
Okay.
property of benzene.
Okay. Yeah, continue.
In benzene, you can element to it.
Benzene, bro. Because it undergoes both addition and substitution reaction, isn't it?
Yes, sir.
And that is the chemical property of benzene. Abby?
Yeah. Yes, sir.
Okay, continue.
Number 3. Which of the following represents a redox reaction? AgNO3 plus KCl will give us a product of A plus KNO3. That's A. B, HNO3 plus NaOH will give us NaNO3 plus H2O.
Okay. Nice one. Are you looking at my can you see my screen now?
Yes, it's showing it has started sharing screen, but I can't see anything apart from that.
Can you see my screen?
It's blank.
It's blank. That means it will soon come up. Just be watching. Once you start seeing my screen, let me know.
I can see it now.
Okay, you can see it now, huh?
Yes, sir.
So these are, you know how to get on YouTube, huh?
Yes, sir.
Okay, this is on YouTube. Once you search for Waec 2018 chemistry, you're gonna see the complete part that I did. You understand?
Yes,
So I'm gonna try to open it now so that it's play, so that you see some of those. You will let me know if your screen is clear and if the visuals are very clear, okay?
okay, sir.
When it starts playing. I want us to take a brief look at it while we continue what we're doing.
So what
Can
did
you
you
see
say?
that? Are you seeing it?
Yes, sir.
So is this similar to your number one?
Yes, sir. It's the same thing.
It's the same bar?
Yes.
Okay. So I want you to listen to it. If you can hear it very well, you tell me. Not my own volume, but the volume of the video that is playing.
I'm hearing it faintly.
Huh?
Faint. It's faint.
It's faint, bar?
Yeah.
Okay. What of the writing? The writing, is it clear?
Yes, I can see it.
The writing can be seen very clearly, bar?
Yes, sir.
Okay. So this is actually the number one question, and it's asking us, okay, I want us to be using this to read out the question so that me and you will be seeing the question while we answer. Is it better?
Yeah.
Is it?
Yes, I see.
Okay. So this number one question says, which of the following raw materials is used in the plastic industry, isn't it?
Yes, sir.
So you can actually get these from under the uses of ethane in organic chemistry. So one of the major uses of ethane is that it is used as raw materials for plastic industry. And it can also be used to hasten the ripening of fruits. So if you check through uses of ethane in your textbook, you're going to see that it has several uses. And it's being used as a raw material for the plastic industry is one of the major uses. Is that clear?
Yes, I see.
So I like the work you did. I checked through your work over the night and I found out that you got most of the answers.
Yes.
But I want you to also get it in context with other things that are surrounded, the other knowledge that you can get in that very in the very question that you're looking at.
Okay.
So I want, when you're able to answer a problem, I want you to be able to, using that same problem, get the context. So which of the following raw material is used for plastic industry? Ethene, which is an alkene,
Yeah.
is majorly used as raw material for plastic industry. It's also used to hasten ripening of fruits in agriculture. So that's very good. So let's look at number two question, isn't it?
Yes, sir.
Good. So I'll play the question, we'll see the question, then after you answer, then we'll look at the way the answer is actually done in such a way that it will cover other concepts surrounding the answer so that the student can, so that you can be able to understand it much better. So can you now tell me other uses of ethane apart from being used as a raw material for plastic industry? Can you do that?
Yes, it can be used to hasten the ripening of fruits.
Good. One or hasten the ripening of fruits. You see, there are some fruit that you see, it did not go through the natural process of ripening because they induced it. So you can use something like ethane to do that. So number 2 question is actually on the chemical properties of benzene. So I'm going to pause this now. I want you to answer this one. Which of the following organic compounds can undergo both addition and substitution reaction? So Chika, tell me.
So I said benzene.
Benzene, isn't it?
Yes, sir.
So why is it benzene? Can you tell me why it's benzene?
I saw under benzene that the chemical properties are addition and substitution reactions. It undergoes through addition and substitution reaction.
Good. So that's the typical property of benzene, unlike these other alkanes. So benzene undergoes both substitution and addition reaction, both of them.
Yes.
Okay. So I'm gonna also let you see the way the answer was done. So with this, you see that you really need to read up organic chemistry. Can you see that? Mm.
Yes, sir.
So once we cover the basics in chemistry, the one we are doing, we're going to go to organic chemistry and look at organic chemistry very well. You're going to mostly see theoretical questions from organic chemistry.
Yes.
Okay. So example of a substitution reaction is the one that benzene has with chlorine to form chlorobenzene. Very, very important. So this very question, you can get the answer from chemical properties of benzene. So can you tell me the difference between substitution and addition reaction in organic chemistry?
In organic chemistry.
Yeah, difference between substitution and addition reaction in organic chemistry.
Addition reaction is like adding an element with another one to give.
Okay, just like you have hydrogen being added to benzene. That's addition. You understand? But in substitution, you have replacement. You have to replace one. Is that clear? So
Yes,
if hydrogen is added to benzene at a temperature of 180 degrees, you have what we call cyclohexane. That is the example of addition reaction.
cyclohexane.
And most unsaturated hydrocarbons undergo addition reaction due to more, they have more than one bond. Is that clear? So addition reaction is mostly for unsaturated hydrocarbons.
Okay.
So take note of that. It's also very important to know. So let's look at number 3 question. So did we discuss about redox reaction? Yeah, Chika, did we discuss about redox reaction?
Yes, yes, number.
Yeah, I saw the one you solved.
Yes.
Very okay.
Thank you, sir.
So number 4 question, what is number 4? Can you read out the question?
And first says that the process of extraction of iron from its ore is A, decomposition, B, oxidation, C, reduction, D, sublimation.
So what's the answer?
Effort reduction.
Reduction, yeah.
Yes, because removing iron, when you're removing iron from its ore, it's going to reduce.
Okay. So let's look at number 5. Read out number 5 there. Let me hear.
So what did you say? Okay. Number 5.
Yeah, I'm looking at what you sent to me on. You can see my phone back.
Yes, sir. Yes, sir.
Yeah, so I'm looking at your answers. So read out number 5. Let's look at it.
What is the solubility of a salt if 0.4 grams of it obtained on evaporating 200 centimeter cube of the saturated solution to dryness?
Good.
So they gave us the mass and they gave us the volume.
Good. So you can see from the question now that 0.4 gram actually saturated was dotted in 200 cm cube. Huh?
Yes, sir.
Is that so? The solubility is the one that will dissolve in 1000 cm cube, isn't it? So
yes,
how did you do it? Did you cross multiply?
Yes, sir.
How did you solve to get your x to be equal to 2.00 gram per dm cube?
I said since 0.4 equals to 200 centimeters.
Good.
Then
X.
I now did what? Yes, x will be equal to, since the solubility we're talking about, 1000 centimeter cube. Then I cross multiply to see my
To make x the subject of the formula, B.
Yes, sir.
That is good. So you did well. Still searching YouTube for so let's go to number 6 question. Read out number 6. Really helping.
Number 6 says an acidic salt has A, double ions in its aqueous solution, B, a single cation in its aqueous solution, C, hydrogen ions in its aqueous solution, D, hydrogen atoms in its aqueous solution.
Process of extraction of iron from yeast. So which is the answer and why? Option A, decomposition.
I chose C,
oxidation.
hydrogen ions in its aqueous solution.
Okay. Answer to this question.
Because an acid uses hydrogen plus another element to form.
Reduction because iron ore is reduced. Let's look at number 7 by carbon.
Did you hear me?
Yeah, I heard you. Formed by the action of carbon 4 So read out 7.
So what 7? A reaction is if A, the reaction vessel feels full during negative. B, bond formation. D, heat formation exceeds heat formation and production.
Your voice is cracking now. Maybe your network is becoming poor. Couldn't get you very well. Can you come again?
Let me check.
And this CO is actually formed. This is the process from extraction of iron by the
Sir?
action.
Should I read it again?
Yeah, please.
CO2, which is carbon.
I said a reaction
White coke.
if a reaction, the reaction vessel feels full during during the reaction. B, enthalpy change is negative. C, bond forming energy exceeds bonds breaking energy. D, heat of formation of reactants exceeds the heat formation of product. Did you hear me?
Yes, I got you.
In chapter 4, iron.
So let's look at the
So
next
I
one.
chose A as my answer.
You chose A, yeah. So let's look at the next one.
Chemistry textbook. So when you have
Okay, so number 8. In which of the following compounds does hydrogen form ionic compounds?
Okay.
inside the corner,
You check my.
there are reactions going on. So when you have your CO2 reacting with white coke, you are going
Number
to
8.
CO.
In which of the following compounds does hydrogen form ionic compounds?
React with your iron oxide.
And they said I chose NaH.
Iron oxide is actually called hematite.
Okay.
I will now read it.
Sir, can you hear me?
Yeah, I can hear you.
I said I chose NaH because an ionic compound is formed when a metal and a non-metal join combine.
Okay.
So Na.
Okay. Let's check out the next.
H is
Let's check out number 9.
Number 9.
Yeah.
Consider the following reaction equation. BRO, bromine plus this potassium Ki, 2Ki will give us 2KBr plus iodine. Said what is bromine acting as? What is the function of bromine here?
Yeah.
I chose reduction because bromine is 0 here on the reactant side is 0. And 2K, if you look for the oxidation number, you see that is -2. So from 0 to -2 is undergoing through reduction. And they said when something undergoes through reduction, the agent that is helping it is called an oxidizing agent.
Nice one. That's very smart. That's very smart of you. You're impressing me. I'm impressed. Okay. So let's look at number 10.
Number 10.
Yeah.
An organic compound has the empirical formula CH2. If its molar mass is 42 grams mole per dm, what is the molecular formula? H, then it gave us H is equal to 1.0 and C is equal to 12.0.
Okay.
So I equated CH2 to 42 and I substituted like
so why is CH2? Why is CH2 equal to 42?
because of the empirical formula and the
Yeah.
molar mass of it.
The molar
Molar
mass is
must be equal to the empirical formula.
good.
So for carbon, you use 1. Carbon
Okay.
does not have any, it has only 1 there.
Yeah.
You do 1 times 12 plus hydrogen, 1 times 2. Hydrogen is having 2 added down, so it will be 1 times 2. When you add that, it will be 12 plus 2. That will give you 14N.
No, wait. You're being fast, eh? The place where you have CH2
Yes,
equal to 42, that's the first line in your solution, Abby.
yes, sir.
CH2 is equal to 42.
Yes,
Abby?
sir.
Now, you're actually supposed to put in bracket N.
N.
Abby? Now, the
Yes,
C
sir.
there, C has 12. And is only 1. That's why it should be 12 times 1.
Yes, sir.
Abby? Carbon is 12. The molar mass of carbon is 12, isn't it?
Yes, sir.
And it's only 1 carbon. So it's now 12 times 1. Whereas that of hydrogen is also 1. But there is 2 hydrogen. So you now say 1 times 2, Abby?
Yes, that is 2. So it will be
Yeah.
14N.
Yeah, why I'm asking you this, because you arranged it and then you came to hydrogen, you arranged it in another way. It's supposed to be 12 times 1 plus 1 times 2. But though it will still give you the same thing, but I want you to know what you're representing, whether it's the molar mass or the number of the molecule atom. You understand?
Yes, sir.
So you have to be consistent so that I will know this the one you're choosing. So continue now, continue.
So after getting my N, I then substituted it in the molecular formula.
Okay.
Like this, since N is 3, it will times CH2. Since we've gotten our N now, we substitute inside that formula. So it will be C3 times H2. That H2 will be H2 times 3, that is H6.
Perfect.
And that will be the molecular formula.
Perfect. So let's go to the next one.
11.
Yeah.
Ethene is produced from ethanol by A. Decomposition, B. Hydrolysis, C. Ozonolysis, D. Dehydration.
So what's the answer?
I chose dehydration because if you want to, like ethanol, the only way it can be reduced is through. I was going to choose reduce, but since another word for reduce is like you can dehydrate it. I chose dehydration. I
Okay.
don't make
So
confused.
look at number 12. Read out number 12, please.
Number 12.
Yeah.
Then consider the following equilibrium action. 2AB plus B will give 2AB3. And they put the enthalpy is equal to minus X kg mole per dm cube. Are you listening?
Yeah, I'm listening.
The backward reaction. Okay, sir. The backward reaction will be favored by A, a decrease in pressure, B, an increase in pressure, C, a increase in temperature, D, an introduction of positive patterns.
Yeah. That's
So did you hear me?
yeah, I had you.
So my answer is A. I got it by 2AB has 2 volumes there in front of it. The number of 2AB is 2 volumes. B has 1 volume. Then 2AB has volume. So the reactant side has more volume plus 1, that is 3. and the product side has O2 volume. So do you understand that up to that?
Yeah, understand. This is
So
under equilibrium. I hope you know it's under equilibrium, huh?
Yes, sir. Yes.
You know about
Following the Chanter's principle.
You know about Le Chatelier's principle?
Yes, sir.
Okay, you know about Le Chatelier's principle, huh?
Yes, sir.
Yeah, so that's the principle that you consider when doing such calculations. Okay, so let's look at the next one.
Yes, sir.
And the next one is question number what?
13. What is the mass of solute in 500 volume of 0.005 mole per dm cube of H2SO4?
That's number 13, ma.
O as 16 and S as 32. Okay. Yes, sir. So,
okay, continue.
It said, what is the mass of the solute in 500 volume? So I did 500 volume will be equal to 0.05 mole per dm cube. Then I now introduce 1,000 centimeter cube be equal to X, since we don't know what the mole per dm cube is.
Okay.
Are you there?
Yeah, I'm here. I'm listening.
When I got my mole for 1,000, I now substituted it in the molar concentration. In titration, there's one formula like this: molar concentration equal to mass over molar mass.
Good.
So I've gotten my molar concentration at 0.01. We don't know what the mass is. That is what they're asking for in the concentration, in the question.
Okay.
The molar mass is gotten by adding the 32, 16, and 1. Like you do the H2SO4.
Yeah.
Then H represents, since H has 2, okay, yes, you add them all together. I'll give you 98. When you cross multiply, you get the 0.98 grams. That is for the mass. Then since the question asks, what is the mass of solute in 500 grams, 500 volume, you now equate it. Since 0.98 equals to 1,000 volume, that means we do what will X equal? X will equal to 500 centimeter cube. So I cross multiply and I got 0.49.
That's very good. So let's look at the next.
That's my mass for.
Yeah.
Pure water can be made to boil at a temperature lower than 100 degrees Celsius by. I didn't really understand this one.
Okay.
I put decreasing the external pressure. But I was still a bit confused.
Can actually be made to boil.
Can you see the the video part of it on the screen?
Less than.
Yes, I can see.
Celsius.
Okay.
If the pressure of the atmosphere, in the pressure of the atmosphere, and this pressure of the atmosphere.
What is the boiling point of water?
Is actually
100 degrees Celsius.
Good.
So if the external pressure
it's always expected that water will boil at 100 degrees Celsius, provided that the water is pure. You understand?
Yes.
So how can we make it to now boil
in this case, the external pressure
at a temperature that is lower than 100?
we get this pressure reduced.
So the boiling, the temperature of boiling has a lot to do with the atmospheric pressure. You understand? So when the atmospheric pressure is reduced, you can get the temperature of boiling to be actually be lesser than 100.
By reducing the external pressure.
Okay.
That is how you go about that.
So when they talk about the external pressure, what do they mean? An example of it, is it like the fire or the wind? What are they saying?
Like the pressure of the environment.
Pressure.
You understand? The pressure of the environment where you have the boiling water.
Pressure affects the body.
You understand?
Okay, sir.
So
Yes.
once that pressure is reduced, is further reduced. That's
actually boil at
that's
less than that.
in some applications where you have something like the vacuum pressure to takes place. So you can actually find it under effects of pressure on boiling point. So if you read up effects of pressure on boiling point, you find out that when the pressure reduces, you can get the water to boil at a lesser temperature than the normal.
Hello, welcome. Let's look at this problem.
Okay, sir.
So let's do the next one.
Waec 2008.
Sorry, you said when the water decreases, you can find out that when the pressure decreases,
the
water will.
This is the case. You can see some
it will not boil at a lesser temperature than the normal temperature that it would have boiled normally at atmospheric pressure.
KCl 3.
Is that good or bad?
KCl. These are the substances. Now, at what temperature
Let's say it's good or bad. It depends on actually what you want to achieve.
That off.
You understand? If what you're boiling is going to spoil at a very high temperature, and you don't want it to be, you don't want it to spoil. You understand? So you might want that boiling to happen at a lower temperature so that it doesn't spoil the molecules or the atoms of what you are working on.
Now, if you look at,
you understand? So in high level chemistry, you might need to have something to boil at a lower temperature than the normal temperature that you would have boiled.
Intersection between the solubility curve.
You understand? So whenever you want such a situation, then it's good that you manipulate your pressure in order to get the boiling to be done at a lower temperature.
Then for K and O.
Okay, sir.
Exactly.
So number 15. Yes, sir.
Okay.
Consider the following sketch solubility curve of some substances.
Okay.
At what temperature does the solubility of KNO3 equal to that of NaNO3?
Okay.
So they put the graph. That point where KNO3 and NaNO3 meet, where they are intercepting, you trace it down to be 20.
Because the horizontal is showing the solubility,
Yes, sir.
whereas the down is showing the temperature, isn't it? So at the point of the intersection, both of them are having the same solubility.
Yes.
Abby? Then when you trace it down, you can get the temperature, which is 20 degrees.
Yes,
yeah, you did well.
Number 16.
Okay.
When salt is added to a saturated solution, the salt A dissolves and the solution becomes supersaturated. B dissolves and the solution becomes unsaturated. C precipitates and the solution remains unchanged. D dissolves and the crystals are formed.
You actually get the solution to this. See such under.
Sir, this one too, I was confused.
You said?
I said I was confused too in this one. Because when the salt dissolves, I don't know if salt being added to saturated solution will saturate it or become super saturated. I don't know what to have.
Okay.
And why is the right answer?
When during saturation, you understand, once you've added enough solute, you understand?
So
you have your once you get to that very solubility value, then you have your saturated solution.
That is the answer, because when salt is added, this is the no further, whenever salt is added.
Can you get the volume
to is?
Yes, I'm hearing it.
Okay.
Solution. Whenever you add a salt to a saturated solution, what happens? The salt remains unchanged. So the salt actually remains unchanged. And what then happens? It deposits in solid form. It remains unchanged, but it deposits in solid form. And its deposition in solid form is known as precipitation. So it precipitates.
Okay, so I understand.
Do you understand it now?
Whenever you add a salt.
Yes, sir.
So
what? Because the solution is already at equilibrium, it's already saturated, so it's no longer taking more. You understand? So it remains unchanged. Whereas any extra this thing you're adding, it precipitates, that it converts into solid form. You can visually see.
So it's saturated solution. Let's see if you like this.
Okay,
I think it's very clear from the volume of the video. Okay.
So,
let me.
So number 17. When X was added to a solution of bromine water, the solution became colorless. X is likely to be A, propane, B, propanoic acid, C, propane, D, propanol. I chose propane. Why? Because when you add an alkyne to bromine water, the yellow and the bromine water now becomes colorless. Hello? 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 Oh, Jesus! Oh, so I'm talking to myself. Is that it now? Ain't fair. I'm talking to myself. I'm now the host. Hello, sir. Hello, sir.
Yeah, sorry. Somebody was calling me and I'm using my my phone data.
Okay, sir.
Yeah, please. Let me just log out and connect my my router.
Okay.
So I can receive call at the same time as we are doing.
Okay,
Once I
sir,
jump
yeah.
back, I'll chat you up on WhatsApp.